Why does blood flow out of our bodies when we cut ourselves? Why isn't it like a powder? Why is it a liquid? How does our heart push it? How does it move? How does it go through tubes? Why are they tubes? Why aren't they like conveyor belts pushing like little blood cubes? Does the size of my heart matter? Those are all really good science questions. If you're interested in the human body or animal bodies and you're wanting to look a bit closer at blood, this is the one for you. So we're going to make a blood flow model. I just have a plain empty cup, my scissors, a ball of plasticine, and a cup of blood or water with red food coloring and a tube. Okay. I also have a knife. Poke a little hole in it. So if you're not comfortable with that, get somebody to do it for you. Or be really safe and get somebody to keep an eye if you're not sure. Need a piece of tube? Come on. It doesn't have to be that big. Now, if you have some tubing of different sizes, that's great. It doesn't have to be this fancy stuff from the hardware store. It could be different size straws. Maybe you got some of those bubble tea straws, or you got some of the uh, smaller little wooden straws. Well, I guess you could use a bamboo straw, right? Different sizes, diameter. That will affect some of the flow that you'll experience with your experiment. Then take my cup, and at the bottom I'm going to punch a little hole. Now, if you're going to use more than one, make more than one, it's important that you make the hole at the same level in your cup. Okay, because part of this is to see how fast liquid or blood can move from your cup out through like a blood vessel. That's kind of what we're modeling, right? A vein or a blood vessel. So I'm going to make it a little bit bigger. If I make it a bit too big, that's okay. Perfect. Okay. I got a spout coming out of my cup. And to make sure that it's all watertight, I could hot glue it. But I'm a bit concerned that my little flimsy cup will end up just melting and kind of imploding. So what I'll do is make a little worm and wrap it all the way around the outside of my cup. And on the inside, I've got a little bit poking through. I'm actually going to do the same thing, push in a bit more. Do the same thing on the inside, and it should keep it from moving either way. This one's a bit trickier. I might have to loop it underneath. If you've got small hands, you're in luck. Okay. Now we can push against both sides. It shouldn't be too leaky. You should expect to make a bit of a mess in this one. So a kitchen counter with a towel handy is a good plan. Okay, so on the inside, I've got some putty, a little hole for my straw. My straw turned to its side. I don't want it turned up because then we're requiring it to fight gravity to get out, right? So we're wanting to see how quickly liquid can flow from here out. That's it. All you got to do is pour in your blood. So when you do this, you got to be ready to clean up. You also want to make sure that the amount of blood or liquid you're using is the same volume. Okay, so in real life, I would make sure I'd fill this cup perfectly full, maybe. I pour it into my big cup. I might want to put my finger on the end of the straw and then go. As soon as I do that, you might want to get a helper. Get your timer out and time how quickly it takes for that whole volume of liquid to drain. Record it. So maybe it takes you 1.5 minutes to drain a whole half pint of your pretend blood, which is just water in my case. Then change a variable. So either consider changing the size of your blood vessel, make a bigger one like something closer to your heart, make a smaller one like something you'd have in your fingers. Also change the thickness of this. So I could put tomato juice in there. It would look really cool. It probably will change how it flows. You could try milk. It's a bit thicker. You could try syrup. There'd be a lot of syrup. That'd be, yeah, you better ask. That's going to be a mess. Um, but it'll change, right? Just like humans have different chemicals in their blood, sometimes thicker blood, and it changes the way it goes through. It might actually move slower or faster. So record all your data and think about what effect does thickness have on the flow? What effect does the tube size have on the flow, the rate of flow? So this is pretty cool. Pretty cool fluid dynamics, physics stuff you're doing here. There's so much fun to have, and just get a towel. It's a mess. It's a mess. Have fun with your blood. Cheers. Bye.